Good afternoon, Professor Zhijin Dai.
Yeah. Good afternoon.
So
Yeah. How are you? Oh.
And thank you for accepting the invitation to be the keynote speaker for our session. And we also have 4 panelists today, and I think we should be complete and we're ready. So I will do an opening first, then there will be a 30-minute presentation from you, followed by a panel discussion. And first of all, on behalf of Future Earth Coast, I would like to say good morning, good afternoon, and good evening to everyone who is joining us from around the world on Saturday afternoon. And welcome to today's webinar on artificial cultivation and ecological restoration of estuarine and coastal mangrove wetlands. And we're thrilled to have you here for this important conversation on restoring and sustaining mangrove ecosystems, which is really vital to coastal resilience across China, Ghana, and Australia. And I will be your moderator for this session, and I will briefly introduce our speaker and our panelists. So as you already met, Professor Zhijin Dai, professor at the State Key Laboratory of Estuarine and Coastal Research, East China Normal University, and he's a leading expert in mangrove restoration and coastal geomorphology. We also have Professor Precious Mata, Professor of Environmental Science and Deputy Director at the African Center of Excellence in Coastal Resilience, University of Cape Coast, Ghana. And also his colleague, Dr. Bapantaya Donatus Anuran, and Senior Research Fellow at EOECR, an expert in coastal geomorphology and beach monitoring. We also have our panelist, Dr. Eden Mahu, founder of the Future Ocean Leaders Academy and a senior lecturer in marine biogeochemistry at the University of Ghana. Last but not least, Daniel Roger, director at JB Pacific, and he is an experienced coastal engineer with a strong focus on climate adaptation and coastal infrastructure in Australia. And we will start with the presentation from Professor Dai and followed by a panel discussion to explore practical pathways for collaboration. And we will also explore region-specific challenges and solutions to share transferable insights from science and engineering, and to highlight opportunities for joint research, technology exchange, and capacity building across China, Ghana, and Australia. So it's my pleasure to welcome Professor Dai to deliver his presentation on mangrove restoration practices and innovations in China. So the floor is yours, Professor Dai. Welcome.
Yeah. 小雨could you see my share window?
Yes, we can see your shared slides, and we can also hear you loud and clear.
Yeah, it's okay. Good morning and good afternoon, ladies and gentlemen. Thanks for having me here to introduce the latest work of our group. I'm Jibin Dai from the SKIC of East China Normal University. My presentation is artificial cultivation and the ecological restoration of estuarine mangrove wetlands. The talk is composed by 5 parts. Firstly, the challenge global mangroves are facing. Yeah, as is well known, mangroves are remarkable intertidal plants that have endured the relentless pounding of stronger waves and tidal currents. Since their emergence over 100 million years ago, these resilient species firstly appeared in the narrow coastal intertidal zone and have persisted to this day through their tenacious survival. Mangroves play a crucial role in mitigating typhoons while also trapping sediments from both terrestrial and the marine source, gradually elevating the shoreline and the effective slowing down sea level rise. Thereafter, mangrove is an effective protector for coastal ecosystems. They have vital space, material, and environmental significance, although will only account for 0.1% of the land surface. Mangroves store 50% of OC within the blue carbon ecosystems. However, these guardians of the coast, mangroves are now facing a grave threat as global sea levels rise at an average rate of 3 and 4 millimeters per year. Some studies suggest that mangroves are increasingly being submerged by seawater, deprived of oxygen and struggling to survive, particularly in the Indo-Pacific mangrove. Mangrove may lose over 50% of their coverage due to rising sea level rise. In China, a combination of human activities and natural factors has led to nearly 30% mangrove loss over the past 4 decades. A study published in Nature, Ecology and Evolution warns that without effective restoration techniques, it will be extremely difficult to revive degraded mangrove ecosystems. Recognizing the urgency of this situation, the Chinese government has prioritized mangrove conservation and restoration, issuing a series of policy documents to safeguard these vital coastal ecosystems. As illustrated in the figure, mangroves are caught in a precarious position, besieged from both sides. Behind them loom torrent seawater, rigid and unyielding, forever blocking their retreat inland. Ahead, they face the relentless threat of rising sea levels. Worse still, greedy human activities have encroached upon their habitats, converting continue to mangrove wetlands into construction land or simple farms, where invasive species continue to encroach upon their shrinking space. Today, mangroves are forced to survive in an increasingly confined environment, attacked from all sides. They are truly living on borrowed time, exhausted and overwhelmed. Therefore, the cultivation and restoration of Western mangroves are urgent and necessary. But I have to say, this work is a huge project that refers to a number of difficulties. The following is about the main difficulties about mangrove restoration. The first question is that where should mangroves be planted? Since mangroves are closely tied to tidal flat, their vegetation is constantly battered by the back and forth flow of tides and waves. Subsequently, determining the right location for mangrove plantings is not just geography. It is about understanding the copper system of hydrodynamic, sediment transport, geomorphological process, and the mangrove ecology. We therefore should consider what the possible factors. The second difficulty comes from the mangrove. Mangrove is a really vulnerable plant. A common saying on mangrove is 1 year life, 2 year death, 3 years death out. Why does this problem occur? We identify two key factors. Currently, the natural buckles or plastic plots used for mangrove seedlings are too small, restricting the growth of their sponge-like aerial roots. This results the compression and the deformities as seen in mangroves shown in the figure. The conventional planting method mimics terrestrial forest or rice farming. Seedlings, typically 2 or 3 years old, are placed in the intertidal zone. Or stake is driving into the substrate and the seedlings is tried to eat. So this exposes the roots to prolonged seawater immersion, causing root damage and eventual mortality. The outcome, complete failure, zero surviving mangroves. Ironically, even on the international-based practice for mangrove cultivation, achieving a 30% survival rate is considered a remarkable success. So that means mangrove may completely die within 3 years if we do not take scientific care measures. The vast majority of tropical coastal fisher ponds were originally built on the former mangrove sites. Today, many countries plan to restore these ponds back into mangrove on excellent initiative. However, there are 3 major challenges. One, hydrological barrier. Most fisher ponds are isolated, they see by ocean dikes, especially those located in middle to high intertidal zone. Fisher farmers rely on groundwater pumping or non-pipelines to supply seawater as natural tidal exchange is blocked. To restore mangroves, we would need to excavate extensive tide creeks to ensure complete exposure during low tide and complete submersion. During high tide, or technically demanding the extremely costly process. Soil pollution. After years of aquaculture, fish pond sediments accumulate high concentrations of pollutants. Contaminated water severely hinder the mangrove survival as seedlings cannot establish in toxic substrates. 3. Ecological constraints. Government compensation for fish pond compensation is typically low. In contrast, fish ponds generate high economic returns per acre, incentivizing fishermen to resist restoration efforts through various means. This creates a major barrier to policy implementation as local opposition undermines government initiatives. How to return the pond to natural ecosystem? It is another challenge we need to face. In view of above difficulties, we have proposed a series of on the techniques. In view, these ideas are developed based on temporal and spatial resolution measurement that cover entire Bamboo Bay and China's Bamboo Gulf region, which accounts for nearly 40% of the country's total mangrove forest. We have conducted a decade-long comprehensive study analyzing hydrological sedimentary, geomorphological, and mangrove dynamics. Regarding the first of planting location, this figure is about hydrological and sedimentation measures. Regarding the first question of planting location, we will determine that elevation is the critical factor. Mangrove typically survive in areas near the mean sea level. The challenge lies in developing mangrove habitats in subtidal zone below mean sea level, essentially addressing the seawater risk. To save this, we will adopt a near natural restoration approach using bamboo fencing. The key design features include 3 parallel rows of bamboos, strips with deliberate gaps between them. To staggered arrangement of the 3 rows, 10 and 15 centimeters elevation above the tidal level. This configuration achieves multiple benefits: progressive flow velocity reduction as water passes through the 3 bamboo layers, rapid sedimentation due to controlled flow conditions, capture of suspended sediments. Our measurements show 19% of the total sediments within the top 15 centimeters of water columns, which accounts for just 3 and 5 meters of total water depth. Cost-effective solution compared to traditional methods. Ecological advantage: the gap spacing facilitates basic organism movement. The structure taps mangrove propagules, increasing their settlement opportunities. Validation through control experiments demonstrated. It can be shown this figure. 30% and 140% high sedimentation rates in bamboo treated areas compared to control site without structures. The planting location involves hydrological connectivity considerations. Thereafter, the second technique is creating hydrological connectivity by returning the shore and the channel to natural scenarios where engineered tidal creek networks mimicking natural mangrove ecosystem and established diagonals oriented near natural tidal flats in estuarine zone. This design serves dual purpose. 1. Protecting mangrove stems from being washed away by stronger currents. 2. Facilitating nutrient delivery through the tidal creek systems. Notably, we have applied for and obtained a Chinese patent for this innovative restoration approach. This demonstrates our mangrove restoration project in a simple pond abandoned for 10 years. The photos show heads surrounding mangrove were planted after creating trench modified topography. We established 2 hydrological monitoring stations across these ponds, such as L4, 3, 1 and R4, 3, 2, 1. really remarkable smooth tidal hydrodynamics with gradual transition in water depots and velocities during flood and ebb cycles. This indicates completely drainage of the intertidal flats after each tidal cycle, which is crucial because prolonged waterlogging would cause root hypoxia on the mangrove mortality. This research has been published in Journal of Hydrology. Thus, the flat can be submerged by water from time to time. Regarding planting methods, I previously discussed the cultivation approach using small nursery plots. This method ultimately damages root systems, causing the smoke neck, such as this and this, and for this point, become stunned and deformed as clearly shown in the focus. This impairment prevents the students from performing normal respiration and transpiration when transplanted to natural intertidal zones. The visible symptoms appear first as green leaves that gradually turn yellow, eventually withering and dying. This explains why many firstly and secondly year mangrove plantings appear healthy with partly green or yellow leaves, creating the false impression of viability. In reality, their root systems are already compromised. By the second year, severe root rot sets in, leaving behind the tragic spectacle of mangroves that appear alive but are actually dying from within. These vulnerable mangrove seedlings deserve our empathy. We therefore propose to put them into larger places like spare or larger bowl. Thus, they can have enough room for naturally growing. Specifically, based on our measurements of mangrove root systems expansion during the first 1 and 2 years of growth, we custom designed larger nether pods that provide metal root development space, as clearly demonstrated by the health seedlings in these pods. Regarding traditional vertical pipe nurseries, we've developed an innovative bamboo tube planting method. Small bamboo tubes are installed into intertidal zones. Each tube features a specially designed groom facing opposite to the current flow. Seedlings are planted inside the tubes and can naturally split the bamboo as grow. These photos are survival symbols in these bamboo tubes. Note that, yeah, those apparently were additionally include their ropes. Presently, the current internationally prevented mangrove planting approach employ vertical tube planting with a distant space, which typically achieves survival rates of just 30% at best. We argue that this method simply mimics terrestrial afforestation practice. However, mangrove in international zones face daily exposure to tidal currents and wave actions, making their cultivation fundamentally different from upland tree planting. We would like to suggest aggregate structure, namely keep the mangrove be together, like huddle together for warmth. When the mangroves stay together, they can be much stronger to wear against the interference from outside, like weather and the storm. Based on 3 years controlled experiment study, as illustrated by the stagger photos. The competitive results are striking, where best the clustered planting left photo on the equidistant spacing right panel were implemented. The clustered approach demonstrated significantly superior outcomes within just 2 years. Firstly, our long-term monitoring between 27 and 2023 years, combining field measurements with high-resolution modelization imagery consistently demonstrates that when isolated individual mangrove seedlings ultimately fail to survive, cluster plantings naturally coalesce into self-sustaining communities. Next, along with the application of above techniques, I'm pleased to present several restoration demonstration cases based on innovative technology. Specifically, we have successfully restored to simple ponds to natural environments. The two ponds have a history of over 10 years. The only route for them to connect to the river is on dam, which made the tidal flood is always above the water level. Those cannot fully connect to the outside. So we remove the dam, add new soil on top of the ground, and create crack with the area. Anyway, we build naturalistic trench on the model flat systems that serve as comfortable homes for mangrove forests. Thus, we can have close to a natural system with shore and water coupling. As shown in the figure, the left panel captures the tidal flood at the low tide, clearly revealing the trench modified topography, while the right figure shows the water level rising during the flood tide, indicating a hydrodynamic region nearly identical to natural tide fluctuations. This observation aligns perfectly with the velocity measures presented in slide 14, which similarly confirmed this tidal dynamics. In addition, we further improve the traditional way for mangrove transplant. During the translation of natural growing seedlings from larger pots to the abandoned shrimp ponds were conducted rigorous training for local works, emphasizing strict root system protection during handling and the precise placement within designed intertidal zones. The photograph shows the actual transplantation site. Furtherly, we planted the mangroves in high density zones to promote the competition between different plants. As a result, in comparison with those of the traditional way, the survival rate of mangroves can reach 95%. the traditional traditional plantain. And for this figure, the new approach. Yeah, the second achieve we have obtained is turns non-forest to low-tidal flat into forest. The experiment area is located in the Nanyujiang estuary where to construct bamboo engineering to catch more sediment and increase the flood elevation. Thus, mangroves can grow on top of it. Our research findings demonstrate that cost areas implementing ecological engineering solutions exhibit shoreline expansion rates twice as fast as non-engineered engineered area. Here is the photos from drone and camera. You'll see within 3 years of restoration, mangroves propagate seaward significantly. Meanwhile, the quality of the student environment present obviously improvement. In the end of 2023 years, we firstly found the trail of the snake. The third place we have successful experience is the Pinu Canal estuary, where we have developed a co-construction patterns that considers both mangrove restoration and economic development. On one hand, we promote sediment siltation, bamboo structure. On the other hand, we cultivate first column, escalator, and the tree to create economic benefit. Within our near 10 years efforts, the state import of mangrove cultivation in each more can be saved as high as 95%. At the meantime, we have some scientific achievements. For instance, we have published over 20 patients and 30 papers. Our consulting reports were applauded by the Chinese government. Our work has been fully reported by multi-platform media, showing our leading role in estuary wetlands restoration and green neck construction. In future, we would like to first improve our skill and techniques on mangrove cultivation and restoration. We also have to share our successful experience to global mangrove restoration, like mangroves in Myanmar, and so on. That's all for my report. Thank you.
Thank you so much, Professor Dai, for that insightful and thought-provoking presentation. And we will now move to the panel discussion with all our speakers. And we will focus on building global synergies for mangrove restoration, particularly collaboration across China, Ghana, and Australia. So I will begin with a few guiding questions to our panelists. And my first question is for our panelists from Ghana. So it's for Aidan, Precious, and also Padentire. So what are the biggest challenges facing mangrove restoration in your country, and what local strategies have proven effective?
Okay, good morning, Zayu, and thank you very much, Professor Dyer, for that comprehensive and innovative presentation on mangrove restoration. I'll start speaking, and then my colleague, Professor Mata, and Dr. Donatus will also chip in. Indeed, mangrove Degradation is a big problem along the coast of Ghana. Um, Over the past decade, we have lost one third of our mangroves. And until recently, the last 5 years, there's been quite some efforts that have gone into mangrove restoration. But what are the current challenges that confront these restoration efforts? Uh, most of these most of these challenges are locally driven challenges. Number one, um, mangrove in Ghana is a very preferred fuel wood resource. So it's one of the most preferred wood for smoking fish in Ghana. But in addition to just smoking fish, it is also a preferred fuel wood for the use of local households. So that driver has been one of the key challenges that confronts its restoration because communities cut down mangroves extensively for wood. In fact, the red mangrove is one of the ones that is preferred by communities as fuel wood, and it's even exported outside of Ghana by communities. Another problem or challenge is the fact that um, there is now a lot of agriculture and aquaculture that is happening along the coast of the coastal areas where these mangroves are. And so, again, we have communities cutting down these mangrove areas and converting them into agriculture or aquaculture fields. Another issue is to do with um, urbanization and infrastructure developments along the central to western coast are in I mean the capital areas. We have seen a lot of encroachments. We have seen a lot of encroachments in wetland areas where mangroves are being cut and houses are emerging, industries are also springing up. Then, of course, we also have another problem which is also rooted in our, traditional our land tenure system, where mangroves are also not owned by the states, but they are owned by communities, which makes it very difficult for the state to enforce legislations that seek to protect mangroves. The communities own the mangroves, so it's a rights issue and it's very difficult to deal with. We also have climate change and sea level rise, which is also changing the dynamics of these mangrove ecosystems. A typical example is the Anyanwi Creek in the Volta Delta area, where um, a tidal wave, my colleague Donatos will be able to speak to that properly, blocked the channel, the opening of the creek to the ocean, thereby blocking the seawater from completely going into the channel to create the conditions that these mangroves require to grow. And that has significantly changed the salinity dynamics or regime of the creek, making restoration efforts even difficult because it's taking so long for seedlings to grow. And also, we also have lack of community incentives. So a lot of the restoration programs are also top down. But as I said earlier on, mangroves are owned by communities. And so if we want to go into restoration, we need to work with the communities. We need to involve them right from the word go. I'll leave it here and ask my colleagues to come in before I also make some input on some of the strategies that have worked for us so far. Thank you.
Thank you so much, Eden. That's really comprehensive. And Precious and Papantire, please.
Okay, so I want to add before my colleague Donatus come in addition to what Professor Edem Mahu said, I also want to state the fact that lack of education, limited awareness among of about the usefulness of mangroves, the interconnectedness of mangrove to other biodiversity among coastal communities is also a huge challenge. So communities are actually communities are actually not aware of the benefits of a healthy and flourishing mangrove as compared to their immediate needs. So what it means is that if they are they always want to meet their immediate needs by cutting the mangroves and selling to make income readily to um, survive on. Now, if they are fully aware that the presence of mangroves is able to boost the development of biodiversity, fisheries, for example, fin fish, for example, shellfish, for example, if they are aware that the presence of mangrove actually promotes the thriving of this biodiversity, and through that they can make more income. Maybe they may not be incessantly be harvesting the mangroves for sale and for survival as it were. Now, the second point I want to also raise is in our part of the world, to a few, we don't have many of those things, but then it is prevailing. Hydrological alterations, where we have seen that dams have been constructed on rivers that um, uh, flow into the coastal areas. And these dams, as we may know, as literature may tell us, have reduced the sediment flow and all nutrient flow into the coastal areas to support the growth of mangroves. And if since uh, uh, tributaries of rivers are actually not flowing as they used to be. Spread of seeds of mangroves are not actually the way they used to be. So these are two key things I want to mention as some of the challenges mangrove restoration face in our place. The third one I want to also raise is lack of technology. It's also a key issue that just as Prof. Edai has presented, this is really a thought-provoking presentation, but then we lack technology at our end. Not maybe I should, yes, just put it that lack of technology is also a hindrance, and lack of funds for some of these things, the ability for people to actually wait for these things take place too is also another problem. So let me end it here. Maybe my colleague Donatus will continue, and then thank you.
Thank you, Precious. And Donatus, please.
Okay, my colleagues have said a lot about the challenges. So let me briefly touch on just one or two. Yeah, so apart from what they have said, in West Africa and along the coastline of Ghana, right now we have a major issue of coastal erosion. So, and this coastal erosion is not only affecting the soil, it's eroding everything, houses, mangroves, and anything along the coast. And it's not only the erosion, the solutions that are even coming, and listening to the presentation that was made, if we have to deal with sea level, mean sea level, when we are looking at topography or elevation, it means that the interventions that we are even coming will also affect the exchange between the sea and the land. So erosion is a major issue, and the solutions we are putting in to reduce erosion could also affect the expansion of mangrove forests or mangrove vegetation or ecosystems. The second thing I want to just say, I think it's also an anthropogenic effect. Basically, like my colleague Adam said, in Ghana, most of the issues we are facing are man-made. So we find a lot of anthropogenic effects leading the degradation or loss of mangroves. And pollution is one of them. So it's not only the sediment that will, sand that will silt the mangrove forest. We have most of these mangrove areas, some of them are highly polluted with either plastics or generally chemicals. So it's also a major issue we sometimes face, and all these things lead to the loss of mangrove forests or ecosystems in Ghana. I think there are a number, but we have just mostly anthropogenic and issues affecting mangrove here.
Thank you so
But
much, Donatus.
maybe if I can continue with maybe the
Of course.
solutions or the strategies before my colleagues come back, because yeah. So for me, I think based on the problems or challenges we have mentioned, one key way or one first thing we have to look at is to bring everybody on board. Like when we want to start to plant mangroves, we need to make sure that we involve the community people, let them claim ownership. When they claim ownership of the work or what we want to do, then when we leave, they can take it over. Another thing that I noticed when we were doing some study on nature-based solutions is under education. We should not focus on only the adults. We have to educate the children, the youth. Let's say the children, because for them, they will see it as something interesting and new to adopt, but the adults will have preference because of what they have experienced. Some will actually continue to prefer the gray or the hard engineering structures for their environment. So I think that we should lower the education to the children so that they will come out to accept that mangroves are really very important in several ways, not only to protect the coastal area, but to have their livelihood and then their income from it. Yeah, I will allow my colleagues to come back and then we'll continue. Thank you.
So let me also come in before Professor Edem also come in. Another point I want to add to Dr. Donatus's issues raised include the fact that one effective strategy to be adopted should be presenting to the communities to accept the fact of an integrated, the restoration as an integrated effort which should involve connecting the mangrove restoration to the general economic well-being of local communities, as I've earlier on mentioned, and through the enhancement of other livelihood options. So if we want to restore mangrove, communities should actually see the mangrove restoration as part of linking as something that is linking to their general livelihood. For example, if they depend on shellfish, they should see the connection between the presence of livelihood and shellfishery. And if they depend on finfish too, the connection between healthy mangrove, availability of healthy mangrove environment to the proliferation of finfishes too should also be seen. In fact, mangrove restoration should be seen as a way to improve the abundance and diversity of both finfish and shellfish. Basically, that is what I want to say. And secondly, I feel that one effective strategy which we have adopted at our center is also the employment of citizen science, where through teaching and training of some local communities, we help them connect the general estuarine environment, that is physicochemical, to the health of biodiversity. So where we said that if the environment, water system, the soil system is healthy, biodiversity will also be healthy. So we train the communities, especially women shellfishers, in two of our projects to understand the connection between the physical chemical properties of the environment as against the biodiversity. So that is it. Then we also, another strategy that we also embark on is transfer and sharing of local ecological knowledge among communities. Certain areas have adopted or have local ecological systems by which they propagate or grow their mangroves. When we see that they are bright spots or good things that they are doing that need to be replicated, we introduce that, we actually encourage and ensure that those techniques have been locally transferred to other groups. In our center, we have two major groups that we work with, the Densu Oyster Pickers Association and Nakwa Oyster Harvesters Association. These two associations are women based women groups that are mainly into shellfishery. But we managed to convince them, and they have seen the essence of availability of mangrove to the development of oysters. And then through that, they've been able to regenerate or restore mangrove plantations in their various areas. So the starting point was Densu Oyster Pickers Association, which was located in the Densu Lower Basin. And after they have accepted through citizen science, they know they really can check the environment and all that. We made sure they actually transferred the knowledge they have to the NAQUA Oyster Harvesters Association, which they are also using now to propagate their or regenerate their mangrove in the area. So these are key things. In addition to community involvement, as Dr. Nurin said, I want to also put across. So Professor Mahu can continue from here. Thank you.
Yes, thank you. Thank you very much. Yes, I agree with my colleagues. Despite the challenges, there has been some successes and some restoration efforts that are currently ongoing. So, what local strategies have proven effective? Community-based mangrove co-management is one of the strategies that has also proven effective. My colleagues have touched on that greatly, but I want to just cite a very typical example of one of these community-based restoration programs, which has been very, very impactful so far. We have a project called the REDOR project, which is the regenerative development of Anglo wetlands. And this is Ghana's first combined blue carbon and integrated blue economy initiative, where mangrove restoration is being done with the community, and it has been strongly connected to their livelihood. So far, they have restored close to about 1,500 hectares of mangroves. Through this activity, they have created jobs, over 100 plus jobs for the communities, because we said earlier that the community sees the mangrove as a source of livelihood. And so if you want to go into any restoration, you need to address these livelihood challenges. They also touched on environmental education and youth involvement. Currently, we have a number of school-led mangrove clubs and citizen science activities in the Volta Delta. Recently, we introduced the Coast Snap citizen science activity, where schools take pictures and upload them in our digital platform. Another thing that has really worked is the use of indigenous species. So most of the restoration that is being done is basically replanting with our native mangrove species, which are the Avicennia, the Laguncularia, and the Rhizophora. I want to also just reiterate one of the key points that Professor Mata raised, which is on linking the livelihoods to conservation, and he brought the oyster farming, which is also very, very critical, because the mangroves along the coast also serve as a habitat for the oysters. Most of the oysters that we have along the West African coast will attach to the mangroves. So once we cut these mangroves, we are also destroying the homes of the oysters. And the oysters are another significant source of livelihood to the communities. And so it is important that we look at the problem as a double problem or a twin problem, not just looking at just the mangroves alone, but how even the mangrove degradation is cutting down, is destroying homes for these oysters. And one project that we are doing currently is to look at potential for large-scale oyster restoration, which could serve as a livelihood source for these mangrove communities. Lastly, I want to also talk about science policy collaboration so far. Donatos made a very important point about involving the stakeholders. We have a current project called the Mankoga project, which is using mangroves as nature-based solutions to coastal hazards and erosion. And basically what this project is trying to do is to bridge the knowledge gap, because to restore mangroves, we need to understand the science and complement that with a traditional knowledge. And so what are some of the things that Mankoga has done? We have looked at the blue carbon potential of mangroves. We have also looked at a digital twin. We've done a digital twin simulation modeling where we do what if scenarios, where we have incorporated local coastal hydrodynamic data into understanding what would be the potential for or the success of restoring mangroves in certain areas along the coast when we integrate all this hydrodynamic data into the equation. And so we have also done that. And the beautiful thing about this project was that it was co-designed right from the start with the relevant stakeholders from the community level to the national level, so that any policies that or actions that are generated from the project will be easily taken up by the relevant stakeholders. Another thing, let me touch on this last one that has also worked, is the local bylaws and also the traditional governance integration. So we have mangrove communities where they have leaders, chiefs, community leaders that have, come out with bylaws that restrict mangrove cutting and also protecting sacred areas. This is also another thing that has worked. Although this has not been replicated along the entire coast of Ghana, it has been done in some parts, and we believe that we need to strengthen this bylaws and traditional governance integration. Thank you.
Thank
Thank
you.
you. Before we hand over, one of our colleagues who is also a mangrove expert in Ghana and working with a top NGO, Yempwanu, is online. Daniel Ninote is also a PhD student in our center and has worked over the years with mangroves. And he agrees to share a bit of information. So I will want to give him some 2-3 minutes to also share some knowledge about all that we are discussing. Thank you.
All right. Thank you very much, Prof. Matai. And I'm very honored and happy to be given this opportunity to also share with the team what has been done in the western part of Ghana. Like the earlier presentations have mentioned, we also had a similar challenge and issues with respect to communities not even understanding the importance of mangroves to their livelihood as well as their well-being. So what we did was first to deal with communities as well, to engage them extensively through video screening, drama, to get their buy-in and to let them understand the importance of the mangrove and the consequences or the challenges they were going to face if they continue with their usual harvesting of mangroves. So we did that for some time, and then we later on got the buy-in of the communities. So now there are communities that have actually decided not to harvest the mangroves again. But there are some communities that are already really much indulged in the mangrove harvesting. And there, what we have been able to do with them is to have some buffer along the river banks and along not to harvest there. And we have also taken them through sustainable mangrove harvesting. We've also done what we call, like Dr. Donatus mentioned, the youth in restoration, women in restoration, because for the women, they also get this shellfish, that's the periwinkles and the crabs and all that, and the shrimps from the mangrove. So if we are able to let them understand that if the mangroves are no more there, they are going to lose these vital resources for their livelihood, then they get to buy in. So at the moment, we also tried, when we came to the restoration, we also tried the in-situ method where we were getting proper goods and some seedlings to plant, but the success rate was low. So what we resorted to was the establishment of mangrove nurseries. And here we did 3 species, the red, black, and then the white. That is Rhizophora, Avicennia, and also Laguncularia. And for the past 7, 8 years now, we have restored a couple of degraded areas at the moment. And currently, there are also projects that are ongoing. So there's some lessons that the eastern coast of Ghana can also learn from the western coast. Thank you very much, Prof. And I think I'll just end here. And thank you very much for the opportunity.
Thank you so much, everyone, and all the panelists from Ghana. I think they really shared key challenges and also highlighted successful local strategies, and this is really inspiring. So now we are going to hear from Australia, and welcome, Daniel. And we want to know, from the Australian context, how do engineering would support mangrove ecosystem resilience, and how might they be shared or adapted globally?
Thank you. Can you hear me okay?
Yes.
Yeah. Well, look, there were some really, really good talks, and I think quite different perspectives than what we've got in Australia. and my work goes through the Pacific as well. But at the moment, I'll focus on Australia. So we haven't cleared a lot of our mangroves for firewood. It's actually because of coastal development. The good news over here is I don't think there is that much mangrove clearing going on anymore. The damage has really been done in the past. And once we've cleared a lot of the mangroves and put people and infrastructure a little bit too close to the coastline, there's been a lot of destabilization of estuarine sort of embayment type areas. It's led to a loss of sediment, some erosion, and a lot of foreshore lowering as well, which changes the complete all of the tidal plains. So what we found is one of our largest problems now is bank undercutting of infrastructure. So my day job, I'm an engineer. So most people call me up when something is about to fall into the ocean. No one ever calls me for good things. They call me up. There is a road about to fall in, or some sort of assets or infrastructure. Now we've seen a really big change though in the last 5 years, that when people are looking for engineering help, they're allowing us to try either traditional, rock armor, but more and more people are open to nature-based solutions, it's excellent. It's a big paradigm shift in how they are looking towards coastal protection. Now, unfortunately, they haven't been calling us in earlier though, so we still get called when things are about to break. So even though people are more open to NBS, there isn't the time to get the mangroves established. So I think in Australia, it's been a case study of more hybrid solutions. Because of the bank lowering, we've had to use a wide range of different engineered structures to bring back the sediment first before we can then implement our mangrove restoration jobs. So I really liked the talk from Professor Dye earlier about the bamboo he's been using and a few of the poly bags. The other approaches we've been using in Australia, we do lots of rock fillets, which are it's a different way of using small scale riprap or bank armor. We're making almost small nearshore breakwaters to collect the sediment behind it, to start establishing the site for mangrove establishment. Down in, there's a bit around where I am in Queensland and also in Melbourne, we've got a new tool out there called a bamboo basket. And you can find them online now. They sell them. They're these little baskets that you can put into the ground, similar to the bamboo approach, but a little bit more sort of fibrous arms going up, and they really help grab the propagules as they're flying, floating around, and help stabilize them. So that's a good low cost one. And there's been more and more work now with different councils and communities trialing different methods. We've got one that's emerging now. It's called the John Eddy method, where it's literally getting a rubber band and sticking a mangrove propagule to a bamboo stake and pushing it in. It's a particular way to do that, and that's got promising results as well. So I think, the difference in Australia is right now, it's not loss of mangroves, it's more focusing on the preparation of the soil conditions to allow mangrove restoration to happen. And we're really going along the principles that if we can get the sediment dynamics right again, the mangroves will come. There's a lot of feedstock over here. They'll float in, but it's taking a little bit longer than we thought, a year or so to get the sediment to come back to an area. And the more creative we are with a bit of engineering in there, we can really do some interesting stuff at the moment. So you'll probably see more papers getting published over the next couple of years from Australia. And they may be relevant for the rest of the world, maybe not. Maybe it's a different challenge we have. But I've certainly liked hearing from the other speakers about the different ways that they are trialing, and perhaps Future Earth Coasts somewhere on your website could be a great spot for more lessons learned in this area, I think. That's it from
Thank
from me in Australia.
Thank you so much, Dan, for sharing. That's really a different narrative. And I think here comes naturally that will come to my next question and also the last question for the panel discussion. For all our panelists, where do you see as the most promising opportunities for global collaboration in mangrove restoration, particularly across Ghana, China, and Australia? And as Dan, you just mentioned, I think on behalf of Future Earth Coast, we are really dedicated to facilitating this kind of network and collaboration. So we hope for this question in today's webinar, it's just to initiate the dialogue, the collaboration, and we could have a continuation. So now, any panelists, please raise your hands or just unmute yourself.
Well,
Any?
whilst I guess I have the mic, I can continue on and
Yeah,
touch on this one. What
sure.
I think I've been listening to a lot of great ideas from the other panelists. I would love to see more failure stories out there, just in case there's been something trialed in Ghana that hasn't worked, or in China that hasn't worked, because that might be the thing that I'm about to trial here. So good news stories are always good, but also sharing the things that we should not keep doing. And, you know, that everyone only likes publicizing the success, but I think finding the failures would be quite good as well, and sharing those is more of a critical review of different sites that for some reason didn't work. I'll hand over to my colleagues.
Yes, I see a lot of great opportunities for collaboration, because obviously the challenges that we are trying to, there are unique challenges across the various countries. Um, but I also think that there is an opportunity to leverage and learn from what each of us has done that has worked so well. Dan made an interesting point that for Australia, it is not about mangrove degradation, but they are actually looking at how they can even create more mangrove areas. And I see that immediately as something that Ghana can actually also learn a lesson from, because from the digital twin simulations that we have done, we have also come to realize that the problem that the nature-based solutions that we are trying to propose to erosion and flooding in Ghana are actually problems that, pertains along the coasts, the beach area. And the mangroves that we have, you usually find them, as we all know, in the intertidal area. Now, our beaches are eroding at a very, very fast pace. How do we bring these mangroves to these areas where the conditions there may not be suitable for them? So that is one area that we can learn from Australia, because you are now trying to grow mangroves in areas that they do not even thrive. Another challenge again is, if we are bringing mangroves, we want to bring, for example, the Avicennia, the black mangrove, to the Four Beach area. The hydrological conditions or the hydrodynamic conditions there will make it difficult for these mangroves to thrive. So this is again where Professor Dyer's solutions or innovations can also come in very, very handy, because you are also looking at how we can plant these mangroves in areas where conditions are not are harsh, how the seedlings can even survive. So I think that these are things that we can also learn. But of course, Ghana has also done a lot of the community-based restoration. This is where we are also, this is where we have our key strengths. And so this is where we can also bring in what can be done at the, across these countries to get communities involved in mangrove restoration. I'll pass it on to my colleagues, Professor Mata and Dr.
Yeah.
Donat.
So thank you, Prof. Maho. I just have just have one point to make relating to the promising opportunities. I think for us in Ghana, this presents a good opportunity for us to come together as various people working at various parts of the country to provide a very congenial environment for the uptake of new technologies that are out there, to collaborate with people to actually bring those technologies to Ghana, then to the West Africa sub-region to improve mangrove restoration. So that is what I want to say. This is more to my colleagues from various institutions, NGOs, public organizations, universities and all, that we are all doing various things in our various closets, where it is high time for us to come together and leverage on the technologies being developed, and then creating the environment for these technologies to be used in restoring our mangroves in Ghana. Thank you.
Let me
Donatus.
quickly just add to what Prof said, because that's a very important point. And I think that after this seminar, we should think about coming out with a joint project, Ghana, Australia, China. But of course, we have also worked closely with Germany in terms of the digital twin simulation. So I think that we could also bring Germany into this joint project if we want to go along that line. Thank you.
Okay, on my side, not much to say, but when it comes to this mangrove, or let's say nature-based solutions in general, yeah, there are a lot of institutions that have operated in Ghana, and I think in most parts of the world. So I support the idea that we include those that can contribute. I also wanted to add that when we are looking at how to restore the mangroves, we could also make it think about something lively for the community, thinking about maybe ecotourism and things like that. And I know those things are all part of the services the mangroves will provide. And I think we can collaborate on these things like that, that will make the communities happy. It will also help maybe make them accept it quite easy or faster. Thank you.
Thank you so much, Donatus. And Professor Dai, any thoughts?
Oh, thank you, Xiaoyu. Yeah, I have some response in Zoom window. Yeah.
I saw it. I want you to mention that also to echo what Anya just left the message. So I think on behalf of FEC, we really look forward to seeing this dialogue being nurtured, and either the Mangroves Association or the joint project proposal Eden just mentioned. And I think we're happy to fully support this and also to bring in partners globally. And yeah, I think this discussion is really inspiring. It underscores that in each region, each country really has unique challenges, but there are also shared goals and mutual benefits in working together to restore and to protect mangrove ecosystems worldwide. And also, I think all the panelists and our speaker and our audience agree that global collaboration is really vital. And therefore, we really want to call for more joint research and more training and more knowledge sharing to support healthy mangrove ecosystems worldwide. And I think this brings to the end of today's session. And I want to send a big thank you for all of you, all the panelists, our speaker, and all our audience for sharing your valuable insights and also for the inspiring work you lead across continents. And to everyone attending on Saturday, and thank you for joining us and for your commitment to coastal and estuarine restoration. And we hope to see you at future FEC events focusing on synergizing initiatives to restore mangroves. And we'll continue building global bridges for a more resilient coastal future. Thank you so much, everyone.
I think Professor Forbes may have some questions. Would you like to?
Okay, I think that's a question to Dan. So it makes sense. It makes sense, but there are lots of more questions I could raise, and relative growth rates of different species would be an issue. Is a simple re-establishment of mangroves the final answer? Was there a question?
Can you hear me?
Yes, Anthony.
Thank you. Now, just curious, I mean, the idea seemed to be there was just discussion of mangroves. Now, as far as I know, we still I don't have the final answer in relation to how mangroves zonate, if you like, within estuarine systems. So presumably if there is concern of, okay, we could be using the mangroves as to deal with, say, storm events or so on, presumably you would want to have a species, hopefully a locally endemic one, but which would have as fast a growth rate as possible. In other words, it would be able to reestablish an overall a mangrove environment that much more quickly than other species. Presumably this is something that would have to be considered. Am I right there? Did that make sense?
Yeah, I think
Professor
Dan
could answer that. Professor Dare could address if he understood it.
Yes.
Maybe I missed that one. What was that one? Could you repeat it?
Anthony, can you repeat the question again, please?
Okay. The impression I got from the talk is that we are very generally talking about mangrove restoration. Now, I mean, as far as I know, what they're between maybe 40 species of mangroves around. There are different growth rates. I mean, a pioneer species like Avicennia, we have Avicennia marina, which can grow at a remarkable rate. So if the idea is simply to establish a mangrove area and to some extent disregarding the associated fauna that goes with a really mature mangrove, there'd have to be I would expect that there would be some sort of selection of particular species, obviously that occur within that local area. But would that happen? Is this part of the whole policy or the whole idea of mangrove restoration? Does that clarify my question?
Yes, I think I'll try and attempt it. Yes, so I think you made a very good point that if we are trying to restore mangroves, we need to look at a species that is endemic to the area, but also we need to also look at species that can adapt to the changing conditions or the different conditions that we have. Earlier on in my intervention, I said that we have done the digital simulation along the coast, the east coast of Ghana, and we have realized that the species that we have, most of them are able to thrive in the intertidal areas, especially the red mangroves, which is the commonest one that we have. It's able to thrive more in the brackish areas. Avicennia is the one that comes close to, the species that is more salinity tolerant or resistant. And so if we are looking at having a mangrove community along the coasts, close to the beach area, then we need to be looking at Avicennia as a candidate. And that is where we also want to look at how we can create the conditions for Avicennia to be able to thrive. So definitely it is important to actually look at the species that can thrive or that can, thrive under what condition or at what area we want to restore the mangroves. I don't know if that answers your question, but that was the impression I got from the question.
I think I've got the gist of what I was asking from the tone of what you were saying there. So thank you for that, and I wish you the best of luck in West Africa.
Thank you. Thank you.
Thank you so much, Anthony, for your question. And any other question from our audience? Okay, and I think from today's session, we actually got a lot of inspiring ideas, and we will work on these, and perhaps we will organize a second webinar on restoring mangroves, and we can further discuss the questions, challenges, and synergies, and the next steps we can work on. And thank you everyone for joining us today, and we look forward to seeing you in future events. Thank you.